Welcome to my talk on decoupling with domain events. And I'm quite happy to sort of be the last talk in the slots of announced talks. So maybe you can get out of my talk and have a little seed of idea planted with you about how you can possibly decouple your Symfony applications. And I will not only show domain events, but also some intermediate steps, and have some practical examples to show you the problems. But I will sort of be more on the theoretical side about explaining how to do the stuff, and then the practical implementation details are mostly very application specific. And we will see like how the idea works, and hopefully you will get something out of it, how you can use this for your own applications. So a little bit about me. I'm Benjamin, and I work for a company called Quafu, and we do trainings and consultings for our customers to help them increase their software quality or write high quality software code. I'm also the doctrine developer, the lead doctrine developer, and lead the ORM and database abstraction layer teams, and I'm also a fairly regular Symfony contributor, although that sort of like declined in the last months a little bit. So that is sort of my approach to Symfony. So at my work, or what we're doing, I'm using Symfony in projects quite a lot, and previous colleagues of mine are sitting there as well, so we did quite a lot of Symfony projects. And also most of our customers now at Quafu where I work also use Symfony as a basis. So you'll find me on Twitter at Eberlei. So what will this talk be about? So we'll start with a little bit of motivation, what actually brings me to this, to making this kind of presentation. And from my observation, first like my own observation, like doing it wrong myself, and also now in the last year seeing how customers implement Symfony applications. Symfony and Doctrine itself, being like quite good libraries, do not prevent us from creating code that has very high coupling and then turns into legacy code quite quickly. So just using something like Symfony or any other framework doesn't prevent us from writing bad code and writing code that is like hard to maintain. So what are the actual problems that we're having, and what are the mistakes that we are doing wrong? So most of the stuff I also did wrong. So there are Symfony applications out there I wrote that are also very big and have very high coupling. So the first mistake I think that we're doing quite often is like we're thinking in technical use cases. So whenever we see some problem that we need to solve, we see it from the technical point of view. What has to be done to solve all this like big scope of problems like that are happening right now? And this normally leads to very big controllers. So we have this technical use case in mind that we need to fix and had to be done at some point in some controller. So we put most of the code in there and the controllers get very big. So that's something I see all the time, Symfony controllers getting very, very big. Also, what we are trying to do in most cases is we're trying to find like this big, nice, shiny model of like the world we're trying to model or the problem that we're trying to solve, and we try to make it like very perfect and big and nice, and everything works together very nicely. And by doing that, normally we have like this big monolithic graph of objects that are doctrine entities, for example. If you have like 100 tables, you have maybe 100 entities, and they're all connected to each other through like associations. You can walk from one end of the application to the other end of the application, and you have this huge object graph of doctrine entities that are related to each other in many, many different ways, and it sort of feels like very big and messy. What we also often have is like no real abstraction of our business rules. So we don't tend to focus on how can we find a nice abstraction of this problem at hand, but instead we're trying to put it like where it fits best. And this is normally the controller. So let's try to solve something. Where can we do that most easily? And then it's most easily somewhere in the controller or somewhere in the form or somewhere where it's easy to implement that. And this often prevents us from doing reusability of this code. So we hide the rules somewhere in some component that is related to Doctrine or Symfony or some bundle or something like that, and makes it very hard for us to reuse that. And so we have to write everything over and over again because we can't reuse it. So there's a bunch of problems that happen when using Symfony and Doctrine that sort of drag us into writing one big monolithic application that is very hard to maintain at some point. And we need to find ways to like improve on this and keep making it better a little bit. So what we actually prefer and what most of us would like to have anyways is have small controllers and big models. However, it's really hard to actually get there. Just saying we want that doesn't mean that we can just easily write it this way and then it works and we're happy. If we're using the form component, validation, and all this integrated into our Doctrine entities, then we quickly realize that most of our business logic has to be on those groups. It has to be on the entities, has to be on the validation rules or in the form somewhere. So we really prevented from actually doing what we want just by using all the components together. And there doesn't really seem to be an easy way out. We want to have something that is reusable. If you have rules that happen at different places, we want to have them reusable and not have to write them over and over again. And also recombinable business logic. So if I have some task that is done in some way, then maybe I want to reuse this in another way or maybe rewrite how it works in an easy way. And then also we want to have sort of decoupled bundles. So this bundle approach in Symfony actually sounds very nice to have this bundle handles this, but this bundle has this other use case, and we really would like to have very decoupled bundles. But if we do that in real-world applications, having several bundles for the several features, then we quickly realize that they all interact. So everybody knows about everybody else, and we can go from everywhere to everywhere, and it doesn't seem to work this way. So there seems to be a gap between how we can do it in technical bundles. So if we implement some technical Symfony bundle, it's normally very easy to keep it decoupled from everything else. But once we get into the ugly real world of applications that our customers pay us for, everything sort of fails and breaks down very easily, and it's very hard to find a way how to fix it. So I want to show a little example, and I tried to fit it on my slides, but then it's sort of pointless. I'd rather show it sort of in an editor. So normally, if we have Symfony-related code and we don't try to write nice code or abstractions and just use the way Symfony is sort of described in the documentation and Doctrine is described in the documentation, then controllers easily look this way, very big. So let me explain the example before I show the code. So that's the example is very easy. So it's some mechanism where two users can establish a contact between each other, and they are then declared as friends or contacts or something like that. So a pretty basic functionality. And this normally requires additional processing or additional components to be notified. For example, we need emails to send for the notification. We maybe have some activity stream to show that this event happened in the world. We maybe have some bubble of messages where we have to increase the counter. Two people want to be in contact with you and something like that. And then the other user can accept or decline the contact request. And we also have notifications again for this case. And then we might have many other subcomponents that are actually interested in this particularly action that happens in the system. So maybe we need to synchronize some data from one system to another when the event happens, or we need to do some indexing of data structures, maybe even payment details or something like this, logging, additional information. We could have, depending on the use case, very different tasks that happen once this contact was established between two users. So the amount of like things that can happen in this use case can be pretty big. Many different requirements could be tied to this use case of connecting to users. So I just wrote some code. I'm not even sure if it's executable here, just like sort of wrote a little bit about how this could look like. And normally, this is not using the form component, just using the request here itself. We have some kind of block in the front of the action which maps the request to like the actual objects that we want to work with. So we may use the form component, or we may use the request itself. We're getting the current user, we're getting some ID and some other user from the entity manager. Then we doing performing some operation. So we create this contact request and we save it in the database. And then we get to the point where we actually want to do the notifications. So after saving this, we might do the email notification right here of sending the email. And after that, we want to maybe write an activity into our activity stream. So we have this activity entity here, and we send a message to the activity stream, persisting and saving that. And all this is done and solves our use case of like requesting contact between two users. And depending on the use cases, more and more business requirements can add to this. And this even doesn't even have validation or something like that. So it's still not code that is even production ready. Maybe we need to intercept exceptions here, handling errors in all that case. So the code can become much more complex. And what we are producing here is really all the problems I've described before. It becomes very hard working with this. And this is normally how most of our controllers end up like. So we're trying to maybe improve this, but much of our code may look like this. So what are the different approaches that we can use to maybe improve on this code? The first thing that is normally suggested about fixing this kind of like bigger code blocks is like, why don't you introduce services? Like for the different tasks, you could introduce services and just call the services and let them handle most of the stuff. So if we don't use the approach of writing everything here directly into the controller, we could break it up into a bunch of services. So in case of the confirmation, so not the establishing itself, but the confirmation, we still have like this request handling here before. We can't really delegate this to a service, but we still need to do this in the controller. And then we delegate operations to some services. So one of the services already provided in Symfony, the security context, so we delegate some operation like, is this user actually allowed to confirm this specific contact request? We can delegate to the security component, please handle this for me, instead of like writing everything in there ourselves. And we can like perform some operations on the entity instead of writing them directly into the code. Here, for example, we have some method that does stuff. And here in the lower end, we're actually using, instead of writing the notifications and the activities ourselves, we might start to introduce services to handle notifications, to handle creating the activity items, to handle, in this case, maybe even payment, because you have a service that actually requires payment for establishing of context. So you might separate all that stuff into many different services and combine them. But if you look at the code, I'm using maybe like 4 or 5 services here to connect the use case that is happening here. There's still lots of code in the controller. So we still have to get all the services, we have to work on them, and it's still, I mean, it's pretty readable because it doesn't go too deep in, it's just like linear code, but it's still like a lot of it, and it's not fitting onto one screen. And this doesn't make it easier in the long run as well. If we have a very big controller handling two different services, it's still not very good to understand. So using services to extract logic improves a little bit on the problem, but it doesn't help us all the way. And since I'm not using the form component here, I'm not sure, maybe somebody of you has tried that. if you're using the form component to handle mapping the request on your doctrine entities, then you can't actually do this sort of in a service. I mean, you can extract that into a service if you want, but then the service needs the form component as a dependency as well. So you're not really improving on like abstracting your business logic. You still have the big form component in there handling all the stuff for you. So the form component would really makes it a problem to extract something into a service, because it does so much by mapping all this information, validation, and all that stuff. So extracting into services is one improvement that we can do, but it's not helping us all the way. If we are extracting into services, at one point we have to ask the question, how many dependencies does the controller actually have? And this is something that Symfony sort of hides from you a little bit. You don't really realize this, because by default we are all using the in this case, I haven't written it here. We use the controller that is provided by the Symfony framework. And it gets injected the dependency injection container, and we can just grab everything out there that we need. And this often leads to controllers that use very, very many services. So does somebody have a guess maybe about how many services this action here is sort of using? Just wild guess. 5? 5, 10, something like that? Okay. Yeah, it's something between 5 and 10. The base controller has access to 7 services already. So there's access to 7 services through using the method APIs on the base controller. And then obviously we can fetch our own services as well. So the experiment should be like, how does this actually look like if we are using constructor injection for the controller? So if you're using controllers as a service, then we sort of realize that this is really madness what we're doing here. So in this case, just try like finding the different things that we have here. The first is the entity manager on line 11. So let's get the entity manager here. The next thing that we need is the mailer. So let's get the mailer here. And then, yeah, we use the security context down here. Yeah, we use that, okay. Yeah, we use, get user. So I already got fooled. Yeah, so I've not seen that I'm actually using a dependency here already, so the security context. Also, below here, we use the router to actually generate a URL for us, so we need the router. And for sending the email, we actually use render view, so we also have templating. Okay, templating. So we have this requirements. And now we started using services below here, and maybe our refactoring is not final yet, so we also have the services below here, the notifications, activity stream, payments, synchronization, indexing, all that stuff. So we're using, 1, 2, 3, 4, 5 additional services. Now we need to add them if we're like sort of using constructor injection. So the Symfony dependency injection container sort of suggests to us we should use constructor injection, because this makes the dependencies very explicit and we can easily combine stuff and recombine it. But in the controllers, this sort of fails apart because we use so many of those services, and trying to put them into the constructor actually makes us go sort of nuts because so many of them. And it's not very easy to like improve on this. So one idea that is not really related to like how this works is I described that in one of my blog posts, is like introducing sort of a service that wraps all the functionality from the base controller and call it something like the controller helper, and have this one here get the container. And it can have all the methods like generate URL, render the view, and all that stuff. And then we can improve quite a lot and remove maybe those 3 services, but it's often quite a bit more of the services that we can remove. So we improved on this by introducing some helper object which aggregates all the controller utility functions. But still, it often leads to very big dependency graphs that get injected into the controller. And this also requires us to write tests using Behat or the functional test case with Symfony. And if anybody has done this like more extensively, then they probably also know that it's really pain in the ass to write more than 10 tests of this, because they're very slow, they break often, and you don't actually know why they break. They just break, and then you have to start like var dumping response objects that have 1,000 lines of HTML, and then like try to find out where the error message is written. So it's really hard working with that. So the way we use Symfony makes it harder for us to like sort of understand how all the dependencies are used here. We're introducing very many dependencies, and they make it very hard to work with in the long run. So creating all these dependencies allows us to do stuff very, very fast, but also allows us to create very unmaintainable code in the long run. And we might need to try to find solutions to that, how we can improve this. So the next question would actually be, to what bundles does the current controller, given that we use constructor injection, so we improved everything and introduced all the services using constructor injection, to what bundles do the controllers actually link? So let's introduce activity stream and notification service here. So if we type in this, what we should do is, like, we have activity stream and notification service. Maybe I should write that here. Make it a little bit more readable. So where do they actually come from? So there are two approaches. One approach is like, let's have this big application bundle. So our whole application is like in this one single bundle. So then obviously all our own services are from this bundle, so the dependencies are okay. But once we're trying to like decouple things, like the bundle philosophy tries to tell us, like, make small bundles of stuff, then maybe we have like the activity bundle, the notification bundle, and the user bundle. Maybe we're using the FOSS user bundle for the user account login stuff, but we also have like the contact bundle to handle all this contact relationship stuff. So we have many different bundles like that are actually used in this in this context. So let's try to like just write some glue code, some example code here, how this might look like in the end. So we have the notification bundle, and it has the activity stream service. And we have, no, that's wrong. We have the activity stream bundle, or activity bundle maybe. Notification bundle has the notification service. So what if we are now in the bundle, contact bundle controller? So what we are implicitly creating by using the container, what we don't actually see in code, is that we are creating dependencies between all the bundles all the time. So the contact bundle has a dependency on the activity stream bundle and the notifications bundle, but maybe does it actually make sense that this dependency exists? So does the contact bundle actually really need to know that there's something like an activity stream or notifications? Not really. But we'll keep creating this all the time because we're just grabbing all the services from the controller, from the container, and getting them where we need them. So to which bundles do the entity dependencies actually link? So we have a bunch of entities that are maybe at place here. I have an example here. So the user might have dependency. The user might be in the user bundle, which extends from the FOSS user bundle. And we have maybe dependencies to contacts, maybe dependencies to the payment module. So even the entities have dependencies between bundles, and it's sort of like messy between all the different components. So now the last question is actually like pulling like the last slap on the problems. Like, how would you actually enable or disable specific features of that, or recombine them? So what if the product manager now comes and says, okay, let's do it this way. We implemented contact establishment the way like Facebook works, but let's change it to the way like LinkedIn works. So like the workflow of how the things are working like changes slightly. At some point it changes, and it might be so complex to change all the stuff because we also need to think about activities, notifications, everything. Everything is at place here, and we can't really easily recombine it because we put it into this really big problem. And the problem we're creating here is like sort of an anti-pattern called the big ball of mud. So we have like this really big system which is all connected to each other, and everything looks like really dirty. And the picture here actually shows a mud volcano. So this is actually a much better picture. At some point it's going to explode and the mud is like everywhere, and it's like really nasty situation. So how can we try to fix this? So service dependencies is one way of fixing it. The service dependencies is by applying the dependency inversion principle, which is from the solid principles. One way of doing this, or solving this problem here, is instead of using the activity stream and the notification service here, actually introduce interfaces in our contact bundle. So the contact bundle has activity stream interface and notification service interface. And we have implementations from our other bundles that implement that. If we use this extensively, then we get lots of interfaces, and the different components all need their own interfaces. Maybe we extract them into a core component. It's a good solution for some of the services, but if you're trying to push this too far, you get really lots of interfaces and implementations, and it's not really helping you a lot, but you're removing the dependencies between bundles at least. So this would be the example I've shown here. The contact controller gets interfaces, and they are from the same bundle, and the implementations are from different bundles. This is one way to fix the service dependencies, but obviously this doesn't reduce the code in the controller. We just switched one implementation for an interface. So how do we fix the entity dependencies? So when the entities have dependencies between the different bundles, how do we fix that actually? This is a problem that has been described by Eric Evans in domain-driven design. It's a concept called bounded context. We have to force ourselves not to write this big model of stuff. We don't have to make it all interconnected, but we have to find boundaries between the stuff and connect and really make explicit boundaries between the different parts of our model, because they're not connected to each other in most of the cases. They're just loosely related. So this is a concept that helps fixing entity dependencies. For example, in our use case, we could introduce some kind of correlation ID. So the user ID is actually the ID that is correlated between the different contexts. In my user and contact use case, I have a user ID. I'm working with user IDs. The activities also sort of work with user IDs. They're displayed for specific user IDs. And the purchasing or the payment context also works with some kind of user ID. So I can correlate all the entities using a user ID. But I don't necessarily need to connect them through their associations and doctrine and make this big graph of objects I can walk along. Because if I do that, then I can't really replace specific parts of that. If I have 100 entities and they're all connected to each other, then I can't really go and extract a little bit of that and say, okay, I want to re-implement that using some other database technology. Because suddenly, like, everybody is using that and it's sort of connected to doctrine, you can't, it's really hard, like, splitting this out. And if you're making this small models and small context, it's much easier to think and reason about the models and use them. So this still leaves us with problems. We still have a hard-coded process and workflow. So we still have in our actions sort of a recipe of how everything works. We can't really like change it without like changing most of the code. We also still have way too many dependencies in the controller, so we need to fix that still. And what I think is a real problem is like we have this cognitive overload of we have to think about everything. Everything is there, everything is used, and we have to understand all that stuff to actually make a change in the code base, because we need to understand what the side effects are and all this problem. And this really makes it hard in the long run to work on applications. So one way to solve the decoupling of applications even more is by using events. So what is an event? An event is defined or can be defined as a significant change in state. So we have some state somewhere. Maybe it's a doctrine model, maybe it's a Propel model, or some kind of model we built ourselves. It's some data in our application, and it changes. This is an event that happens in the system. And even by us not using like the event dispatcher or the event system from Doctrine, the event still happens. Events happen all the time. We just don't use them like explicitly in code. They just happen all the time. Every time a state changes, an event is actually happening in our system. How does this normally work if we're using this in applications? So we have some kind of state that is changing. For example, we have a new contact request in our system. So obviously, like a contact request was created. And for this event that happened, we can create a message object that represents this event that happened. And this message object can be passed into some event dispatcher, event publishing mechanism. And then the event dispatcher knows about everybody that wants to be kept informed about this event. And they can say, oh, nice, this event happened, so let's do my work. And using events introduces one indirection into the system by using this event dispatcher that allows you to decouple components even more from each other. So instead of writing everything into the one controller that is happening, we can focus on the actual event that is happening in a controller. So in our case, here, the request action actually ends at this point here. At this point, the business use case is done that the user had to fulfill. He requested a new contact to another user. And essentially, what we're the business use case is done, and what now is happening is we need to fulfill some UI requirements, like some email has to pop up somewhere, some notification has to be somewhere, and this is just additional stuff that is technically required to make this actually usable for the end user, but it's not really required for the business use case anymore. So we can improve on this by using events. What do events have for technical implications? So using events in your system, as I said before, introduces a layer of indirection, and we will see how this looks like. And we have to think a little bit about how this works and how this may make our applications maybe a little bit more complicated and how we can deal with that. So event messages in the best of all worlds don't have a return value. If an event has a return value that has to be passed back to the system where the event was called, then you have interaction again between the different components, and this makes it really complicated to think about that. And in this case, I wouldn't actually recommend using events, but instead keep going on with the interface approach I showed before, because then you have interaction between different components, and you should make it as explicit as possible. Events should have no return value, so we should separate them as much as possible from the actual thing that happened. Okay, a typo in the, okay, problem. Events should have no way to stop the execution or stop the propagation. Because if you do that, then you have dependencies between the different event listeners, and then this makes it very complicated to think about it. And if you've worked with the kernel request or the controller request from Symfony itself, they allow you to stop propagation, and most of the internal components use that. That makes it really hard to understand at what priority do I have to have the event listener. And actually, I think in one alpha or beta or something like this, Symfony actually didn't use an event system, but they used a filter system for this, because that's a much better approach. And like after lots of time and like working with the system how it currently is, I would say that like the way it worked with the filtering before was actually much more explicit and sane about what is actually happening there. So the Symfony way of doing like events for the kernel things are not really events. It's sort of like a filtering system, and it makes it really hard to understand what's happening there. So we should avoid that to like reduce the complexity without having to think about like the priority of events. Also, we should try to avoid sending the failures back from event listeners to the system. So if you're sending an event, you actually don't care about who's listening. So if the listener fails and throws an exception that goes back to the user and displays as an error, then it's really, really weird. Because now you have like an event which which the system actually doesn't care about in this case, bubbling back to the user, showing an error message, and it's again increasing the complexity for you as the developer to handle these failures in a sane way and retry or do this again. So a good event system should actually not show the the failures again to the user or to the one who's calling the event system. If we do these three requirements for an event system, then we can actually do this asynchronously, because we don't care about the return value, we don't have one. We don't care about stopping the execution, we don't care about failures. So in this case, we can just put it into a message queue and do this asynchronously. And this also makes the system much faster, because sort of things like sending emails, putting activity stream messages up can be done in the background, and the user doesn't actually have to wait for this to happen. If we are doing asynchronous events, then events actually have to be serializable. And this introduces one problem, that you cannot put a doctrine entity into your event object, but instead you have to focus on like just putting IDs and some scalar values in there, because the doctrine entity itself is not really serializable in a good way. You could use the JMS serializer, but this adds lots of complexity, and you have to think about what kind of stuff you want to serialize and what you don't want to serialize. So it's much easier if an event is just using some scalar values and is serializable easily. So these are properties of an event system that make it very easy to use. Then there are two technical things that come up. I want to just go through very simple, easily. If you're thinking about event systems, then you have to ask yourself, should the sending of the event be part of the transaction of the database? So do you want to have an ACID-compliant event system, sort of, that requires two-phase commit and lots of implementation details, quite complicated to do? The other way would be to say, I don't care about quasi-transaction. I can use sort of like the eventually consistent approach. This is also possible, but adds complexity on another side, because you as a developer have to handle failures and retries and all that. So using event-based architecture introduces complexity, and you have to think about using ACID or base transactions and handle them appropriately. So these are the technical implications. What are domain events now? So what is the topic that we're talking here about, actually? So normally, if you go on projects like from the Symfony world or Symfony doctrine related world, then we are using events quite a bit already because the frameworks provide them for us. So a typical discussion between two developers could be, where do you handle the case that I want to send an email for the newly established contact between two users? So you can implement this in Symfony quite easily using a doctrine event. So I could create an event listener, and the developer B says, I have a contact request created pre-persist listener, and in the pre-persist event, I send the email. Okay? Next question from developer A. But now, how do you handle the case that we also have batch imports of contacts? So there are batch imports, and the users don't get the emails in this case, only in the case where it's done through the user interface. So developer B says, yeah, okay, very easy. I hooked into the kernel request event, and then check if like the on-kernel request event is set. And I set a Boolean flag on my listener so it knows I'm in the web context. In this case, I can send an email. So what we're doing here using the Symfony and the doctrine events, we are tying our business logic to the events that happen in the doctrine and in the Symfony systems. And it ends up putting our business logic into very weird places. So like this discussion is very weird, because like this actually doesn't make sense in the business rules. Like, why should this happen in some doctrine Symfony related event? And developer A could like go to the developer B, okay, thank you very much. I just added this new module in the admin section where somebody can upload the CSV file to add the contact files. And this is in the web context, so everybody got an email. Yay, I've introduced a very weird bug where suddenly all the imported users get an email. And I see this quite a lot, where we try to put business logic into the Symfony events and the doctrine events. And this gets even more weird if you're using the doctrine pre-update or post-update events, where you have to check that a specific field has changed. For example, if we would try to introduce an event for the contact request was confirmed, then we might need to check in the post-update event that the confirmed field was changed from false to true. And if you try to add more and more events this way, you get a very weird looking event handler and you don't really understand why the different things are happening there. So what are domain events trying to solve in this case? First, a note on the Symfony and Doctrine Events itself. Those events are solving problems in their own context. So we have the framework context of requests, and we have the doctrine context of persisting stuff in a database. This might not make sense for your application because they are in a different context and living in a different context. And overusing these events to put lots of business logic in there will make it very weird to find them. And I've wasted tons of hours like trying to find out when some specific listeners are called to like trigger some business logic that is related later. And it's very indirect. So what I told before, like event systems being very indirect, because we have this indirection. This is really much more painful if you're using events that are not really useful in the context, but they are used in different contexts. It makes it much more indirect and much more weird to understand and hard to understand. So domain events try to solve this problem by introducing something, an event that the domain expert actually cared about. So not some event that's happening inside Symfony or Doctrine, but something that actually is useful in the business application that we have. So we have an event state change in the model, and it's in terms of the business, and it's tied to the execution of a use case, and we can write it explicitly in code. So instead of having this indirection, we try to make it the indirection of using events as explicit as possible. And you can even use a mechanism called event storming to find all the events in your system. And this is a picture from a customer of us, and Matthias Veras was there and was doing an event storming session where they found all the events in their system and then developed the system based on the events that are happening in the system, making them very explicit in code. In our example, we might have contact requested, contact established, contact confirmed, declined, and to make the distinction clear about contacts being imported, we also have a different event about contact was imported instead of like requested by a user. So we can make the different use cases very explicit with very explicit events. There are two approaches where how we can implement this. The one way is like very procedural. So if we are having an application already in Symfony, we can easily implement this approach. We have the contact controller, and the contact controller just creates our contact requested event. And then an event publisher distributes that to listeners. How does this look like? In our case, we remove all the code about activity streams, notification services, and all that stuff. And instead, at the end, get the event dispatcher, publish some event that is explicitly called like the event that happened in the domain. And you can, this is actually useful in this use case. We requested the contact and there's an event about it. And all the event listeners can now listen to that, send their emails, send their activity stream, do whatever they need. What have we achieved? We have achieved more loose coupling. So we can remove all the dependencies and use statements in the controller to the services, and we have improved the loose coupling of our applications. This approach works with Doctrine getters, setters, and the Symfony form component very easily. So you can still use all the stuff that is in the Symfony framework. And that allows you to add this functionality to CRUD-like applications that you can do in Symfony quite well easily. And if you're doing CRUD-like applications and working with the form component and maybe even the code generation part of Doctrine and all the stuff, then it's very easy to use this as an approach to decouple logic from the CRUD part of your application. The drawbacks of this are that you have to use the event dispatcher in many, many places. So you introduce this dependency event dispatcher. Maybe you don't care because you're using the base controller anyway, so dependencies are just like falling from heaven. However, the second drawback is that you really don't have a two-phase commit. So you maybe call manager flush, entity manager flush, or some other mechanism to save stuff, and then call the event slightly after that. But you don't really have two-phase commit in making sure that the events really reach the other systems. So maybe there's some failure somewhere, everything crashes at that point, and the database is like written and the events didn't get published. So you maybe have a problem that some subsystems didn't get notified. It's also, in this case, very likely that you forget triggering the event in another context. So because we're implementing the event in the controller, it's actually something that we have to do at every place where this event is happening. So if we duplicate this somewhere, then we have to make sure that the event is also called in this place. So it's a little bit more dangerous to forget calling this. The second approach is something where we handle events as state. So we say that events are also state of our model. So whenever an event is happening, this is also state on the model that we make explicit. And then the code triggers the events from our models. How does this work? In the most simple way, and there are much, much more complex implementations for this. This is just to show the basics. You have an array of events in your entity, and whenever an event happens, like you create this object in the constructor, for example, or maybe in some other method, besides changing the state of the object itself, you also change the state of the events and create this event object and attach that to the events property. For example, if you have the confirm method, you may be setting the confirm boolean to true, and you also create the contact confirmed event here. And then you can hook into Doctrine or whatever persistence mechanism you're using and trigger dispatching all these events to the event listener right when the transaction succeeded, and make sort of like a Doctrine listener that grabs all the events and dispatches them to the appropriate listeners. And this way you have, again, the benefit of loose coupling, but you also have an additional benefit that the events are always created directly when the state changes that is relevant. And we don't really need a dispatcher in our code anymore. It's hidden somewhere in the persistence mechanism. When we save something, the events are also dispatched. So we're saving the state and all its events by triggering them. By doing this, we actually have the possibility to do some kind of two-phase commit, like triggering all the events before the transaction is committed, and then building some mechanism of like rolling back the transactions when the events failed, or building some system like this. And this also enables some very advanced patterns where you actually make, called event sourcing, where you make the events actually the only thing that you save in the system. And you rebuild the model by always using the events that change the state. But this is very advanced and not really required to use domain events. So this very, very simple approach here with a very simple listener for the Doctrine event cycle is already enough to use this approach. And I will show a blog post later from my blog, which has the full implementation of this. The drawbacks of this is that you're sort of like integrating this very deep into Doctrine where the events are actually called. So the indirection here is increased a little bit. And another problem here as well is that you really can't use getters and setters anymore, because getters and setters don't have a context. Calling set confirmed true or set confirmed false, you don't really know who called that method and why. So you need really the context of having non-getter and setter method that change the state. In this case, we have an explicit confirm method, so we know it's in this context. And this makes it much harder to use the form component and use much of the Symfony tooling around like request handling, and makes the implementation much more difficult. So if you're implementing a very CRUD-like application, then you shouldn't use this kind of approach, because it makes the implementation much more difficult and you have to write much more code that is not really usable, not really needed. And instead you should use the much more simple approach of calling the event in the controller. So these are two approaches of using domain events and making events very explicit in your system and building listeners that handle these events. what are the different ways that we can use to decouple our applications? So one approach is, and in most cases it's really helping a lot already, using actual dependency inversion, introducing interfaces and services for our different concerns. Another approach to decouple the applications I've just shown very small is like using this bounded context concept to make our models smaller and make them only care about the explicit stuff they're handling at the moment. And the third part is that actually allows you to make very big gains in decoupling your applications is using events to communicate between different bundles and between different contexts actually, and make them unaware of each other. And using this approach, we've been able to write applications with very small bundles, and they don't know about each other anymore. They have some events and communicate through some events, and they do stuff based on that, and you don't have the problem anymore that when you're looking into one bundle, you actually have to understand all the 700 other bundles that are used as a dependency and making it much more complex to reason about things. Okay, the slides will be on Joined-In. I will show the link shortly, where you can rate my talk and see the slides. There, in the slides there are links to 3 blog posts from my blog that show these concepts in more detail, and you can read about the different things I've told. And there's also one blog post by Matthias Verras, I told before, about decoupling Symfony from forms more. So the different concepts are shown here are in this blog post. I think I'm already over time, so maybe I can like answer 1 question, 2 questions. There? Do you have any best practice for naming events? So the question was if I have any best practice for naming events. Since events are changes in state that happened, when I create the event object, the state change has already happened. So events are in past tense, so they already happened. So I write the event class in past tense, sort of like contact request requested, so it was already done, so they're in past tense. And I try to write them in the actual domain concept or the actual domain event that happened. So if the guy I'm working with tells me a use case about like, yes, somebody clicks on the button to request the contact, and then so you realize from the language something happened, and then like he gets notified or something like this. So I'm trying to using that one. But the most important thing is like to write them in past tense. Okay, one more question. Okay, yeah, so obviously the question was, how do I find out who listens to which events? As said before, events sort of introduce lots of indirection in your system, so you need to understand at some point what event listeners listen to which events. And there are different mechanisms for that, because in Symfony you're probably using tags for the events. You can build command tools which allow you to show that somehow using the console command. And using that information, you maybe even can build yourself something that displays this in the debug toolbar or something like this. But I think it's very necessary once the system gets bigger that you try to visualize this somehow, who is listening to what. Yeah. Okay. So thank you very much. You see the Joined-In talk link there. I will put up the slides there, and you can give a rating on my talk if you want. Good or negative comments, anything is appreciated. And thank you very much for listening. And much fun with the lightning talks, and yeah, maybe we see each other tomorrow at the Hack Day, and then come back home well, and yeah, see you next time.
Just quickly, someone